we have talked about how we construct and use the model. Now, we need to learn on how model itself works. Decision tree is a technique or model falls under classification. Let us take a look at the example of decision tree. We will discuss further from now on how decision tree works. We need to have a root or parents, or this can be also known as splitting attribute to build the decision tree. Let us make a simple example. Now, take a look at the first attribute and we say that this would be the root. However, actually, the first attribute is not simply appointed as the root. We will learn in detail later on. If we take a look at the refund attribute here, let us make some rule by relating this to what we want to predict. That is class of cheat. So this is the class, okay, cheat, with value yes or no. Look at the trend of rule here. I'll give you a minute to take at the trend of the rule. Compare this with the class label. Yeah? Look at the trend of the rule. For TID1, 4 and 7, if the refund is yes, then cheat will always be no. Correct? Let us try drawing the tree. So we start with the root. So this is the root would be refund. Refund will give two value of the class, that is yes or no. So if refund is yes, so the class would be no. If refund is no, look at if refund is no. Sometimes, okay, the cheat class will be another value. So for example, this is no, can be no. Sometimes it is said no, but it can be yes. So we can deduce that the class need to depend with another attribute now. Therefore, we will expand the tree by adding another attribute. Let's say the second attribute, that is marital status, as the splitting attribute. So let us construct the if-then rule for the second attribute. Please bear in your mind that you need to include the first attribute as well in the if-then rule. So I'll give you another minute to take a look at the marital status with refund and compare it with the cheat class. if refund is no, and marital status is married, refund is no, marital status is married, then the cheat will always be no. So we can draw another level of the tree here. So this would be the splitting attribute, that is marital status. So say that if refund is no, but with marital status married, then the class label of cheat will always be no. However, with another category or value of marital status that is single, or divorced, take a look at refund no, yeah? Don't take a look at refund yes. There will be different value of cheat class. It can be no or it can be yes. So same as previous, we need to depend on another attribute to predict yes or no cheat class now. So we need to have another level of tree with another splitting attribute. So our next level of tree would be on the taxable income. So let us just make another rule, and level of tree, what we can deduce here is, take a look at the rule. If refund is no, still refund is no, yeah? We are following this path of tree. And if marital status is single or divorced, because once we have met marital status as married, it is automatically deduced as no. But now we need to see another type of marital status. We need to see the taxable income. Split the continuous value of taxable income as 2. Why? Because we can see the trend here. If refund is no, okay, refund is no, but with married, we don't have to see here anymore. Single, marital status is single, and if taxable income is less than 80k, then cheat class will always be no. Is there any other set from here? No more. Okay, but then if refund is no and marital status is either single or divorced, and if taxable income is more than 80k, then cheat class is yes. Let me create for you the rule here. If refund is no and marital status is single or divorced, and taxable income is less than 80k, then cheat class is no. Please refer on your slide as well. Yeah, if refund is no, and marital status is single or divorced, and taxable income is more than 80k, then cheat class is yes. So let me draw the tree for you now. So from here, if the tax income is less than 80k, so therefore cheat is no, while tax income is more than 80k, then cheat class would always be yes. So this is how we construct our decision tree. There is another example of decision tree in this slide. So you can try it on your own using example before. There could be more than one tree that can fit the same data as long as you can deduce the if-then rule.